close your eyes, take a deep breath, and let me tell you about the day winter returned. Imagine this: you're standing 12,900 years ago, watching the last great ice sheets retreat. Spring has finally come after 100,000 years of frozen darkness. Flowers bloom where glaciers once stood. Your ancestors dare to hope. The world is warming, healing, awakening, and then, without warning, winter slams back. Tonight, we're unraveling one of Earth's most haunting mysteries, the Younger Dryas, a 1,000-year deep freeze that appeared like a ghost in the geological record, baffling scientists for over a century. A climate event so sudden, so violent, that it rewrote the story of human civilization. Some call it a natural catastrophe. Others whisper of cosmic collisions and lost civilizations swept beneath rising seas. So settle in. Let the weight of your day melt away. As you drift toward sleep, we'll journey through frozen time together, exploring 50 secrets hidden in ice cores and ancient pollen, in flooded lakes and mysterious stone circles. We'll separate fact from fiction, science from speculation, and discover how this ancient freeze still haunts our future. The story begins in a Scandinavian bog over a century ago. Fact 1. The first clue, 1901. Picture a Norwegian scientist in 1901, knee-deep in a misty peak bog. His name was Axel Blytt, and he was hunting for something invisible: pollen. Tiny grains trapped in mud, each one a fingerprint from the ancient past. That day, Blytt noticed something strange. Layers that should have held warm-loving tree pollen instead showed Arctic flowers. Cold-loving plants. A whisper of winter in the wrong place, the wrong time. He didn't know it then, but he'd just discovered evidence of a climate apocalypse. For decades, this odd pollen signature remained unexplained, a puzzle piece without a puzzle. Other bogs across Scandinavia showed the same pattern. Something had happened, something that froze the world mid-thaw. But what? Fact 2. Naming the ghost, 1934. In 1934, a Dutch scientist named Gerardus van der Schreek gave the mystery a name. He called it after Dryas octopetala, a small white tundra flower with 8 delicate petals. This little survivor thrived in the harshest cold, and its pollen exploded across northern Europe during this mysterious period. The Younger Dryas. Even the name sounds like a whispered secret, but naming it didn't explain it. Was it local, a Scandinavian quirk, or something far more terrifying? A global event that had plunged the entire planet back into ice? Fact 3. The ice remembers, 1960s. Fast forward to the 1960s. Scientists at Camp Century, deep in the Greenland ice sheet, were drilling into frozen time itself. Mile after mile of ice core rose from the depths, each layer a frozen archive of ancient atmospheres. And buried in that ice, in the ratios of oxygen isotopes, they found the truth. The Younger Dryas wasn't a local event. It was cataclysmic. Temperature records written in ice revealed a plunge so dramatic it seemed impossible. This wasn't gradual cooling over millennia. This was winter returning in the span of a human lifetime. Imagine watching your grandparents' green world freeze solid before your grandchildren were born. The ice had recorded Earth's scream. Fact 4. The Staggering drop, 1993. By 1993, the GISP-2 ice core project revealed numbers that still make climatologists shudder. Greenland's temperature had plummeted by 10 degrees Celsius, 18 degrees Fahrenheit, within just a few decades. Some estimates suggest it happened even faster, perhaps in as little as 10 years. Think about that for a moment. 10 years for a world to freeze. Our modern climate changes fractions of a degree per decade, and we're already seeing hurricanes intensify, ice sheets crack, forests burn. The Younger Dryas happened 20 times faster. It was climate change on fast forward, a planetary convulsion that redefined what Earth's systems were capable of. And the ice cores showed something else, too. The freeze ended just as abruptly. One day winter, the next generation spring. Fact 5. The global witness, lake sediments worldwide. But Greenland is remote. Could this have been some regional anomaly? A northern fluke? The answer came from lakes. Quiet, patient lakes scattered across the globe, from the Swiss Alps to the mountains of Japan, from the American Great Lakes to the highlands of Colombia. Each one a witness, each one preserving mud layers that told the same story. The world had frozen together. Swiss lake sediments showed glaciers surging forward. Japanese pollen revealed forests dying back. African lakes recorded droughts as rainfall belts shifted south. The Younger Dryas wasn't regional. It was hemispheric, perhaps even global, a planetary reset that touched every continent, every ocean, every living thing. The evidence was mounting piece by meticulous piece. Fact 6. When forests became tundra. Imagine walking through a primeval forest, towering pines, graceful birches, the soft carpet of moss underfoot. Birds call, life hums, then you blink and it's gone. This is what the pollen record shows. Forests retreating, withering, disappearing. In their place, grasses, cold herbs, hardy shrubs clinging to frozen soil. From Germany to Canada, the tree line collapsed southward by hundreds of miles. Parkland became prairie. Prairie became tundra. The earth changed its clothes from green to gray. These pollen shifts gave scientists a calendar of catastrophe, tracking the freeze year by year, century by century. And they revealed something else. This wasn't just cold. This was dry. Precipitation patterns shattered. Rivers slowed. Wetlands vanished. The combination of cold and aridity created a desert of ice. Fact 7. Dating the disaster, corals and stalagmites. But when exactly did this nightmare begin? The answer came from unlikely places: coral reefs in the warm Caribbean and cave stalagmites in distant China. These natural archives, thousands of miles apart, both preserve climate signals in their growth rings. Like tree rings, but made of calcium carbonate, building year after year after year. And they agreed, approximately 12,900 years ago, give or take a century. The Caribbean corals showed sudden cooling. Chinese cave formations recorded drought. Independent dating methods, uranium-thorium in stalagmites, radiocarbon in corals, all converged on the same moment in time. This wasn't guesswork anymore. This was precision. The world had a date for its near-death experience. Fact 8. The abrupt awakening 11,700 years ago. And then, just as violently as it began, it ended. Around 11,700 years ago, Greenland warmed by 10 degrees Celsius in less than 50 years. Some ice core sections suggest the shift happened in a single decade. Imagine being alive when the world thawed. One winter, your people huddle against the killing cold, burning precious wood, rationing dried meat. 10 winters later, your children splash in streams that didn't exist, picking berries from bushes that sprouted in newly thawed soil. This is the speed we're talking about. Generational whiplash. The abruptness is what terrifies modern scientists. Because if Earth's climate could flip that quickly once, it could happen again. Our comfortable, stable Holocene, these 11,700 years of relative calm we've enjoyed, might be the exception, not the rule. Fact 9. Dust and desolation. The ice cores revealed another clue. Dust. Lots of it. During the Younger Dryas, dust layers in Greenland ice tripled. This tells us the continents were drier, vegetation was dying, and winds were howling. With fewer trees and grasses to anchor the soil, deserts expanded. Dust storms raged across barren landscapes, carrying sediment thousands of miles before depositing it on ice sheets. You can imagine it, a world of wind and dust, where survival meant finding shelter from relentless gales. The dust also affected the climate feedback loop, reflecting sunlight back to space, potentially amplifying the cooling. Earth was caught in a vicious cycle of cold breeding cold, dryness breeding more dryness, planet struggling to breathe. Fact 10. Precision through wiggle matching. By the 1990s, scientists had perfected something called radiocarbon wiggle matching, a technique of cross-referencing carbon-14 dates across different proxies, from tree rings to ice cores to lake sediments. It's like solving a jigsaw puzzle where every piece confirms the others. And through this painstaking work, they pinned down the Younger Dryas with remarkable precision. 1,200 years of deep freeze. Not 1,000. Not 1,500. Exactly 1,200 years. Give or take a few decades. This precision matters, because to understand what caused the Younger Dryas, scientists needed to know its exact timing, its speed of onset, its pattern of recovery. Every detail mattered, and now they had those details recorded in ice, in mud, in stone. The stage was set for the next question. Why? Fact 11. Winter's return. Let's set the scene again, because the context makes the catastrophe even more stunning. For 100,000 years, Earth had been gripped by ice. Glaciers 2 miles thick covered Canada, Scandinavia, Russia. Sea levels were 400 feet lower. Britain was connected to Europe by dry land. Then, around 15,000 years ago, the Great Thaw began. Ice sheets cracked. Glaciers wept meltwater. Spring, at last, was coming to the world. People expanded northward, following game, finding new lands. And then winter slammed back, like a door closing in their faces. Imagine the psychological shock, the cruelty of hope snatched away. This wasn't the gradual cooling of an ice age. This was a betrayal, a false spring followed by winter's iron grip. For the people who lived through it, it must have felt like the gods themselves had turned against humanity. Fact 12. Frozen oceans. The North Atlantic became a nightmare of ice. Sea surface temperatures plummeted by 5 to 10 degrees Celsius. In some regions, the ocean surface froze where it had never frozen before. Ice rafted debris, boulders carried by icebergs, crashed down onto the seafloor, leaving scars geologists can still read today. These weren't gradual changes. These were shock waves rippling through Earth's circulatory system. The ocean, you see, is the planet's heat distributor. Warm tropical waters flow north, releasing heat, keeping Europe habitable. But during the Younger Dryas, something disrupted that flow. The conveyor belt of warmth stuttered, maybe even stopped. And when the ocean stops moving heat, winter expands. Fact 13. Grasslands of giants. With forests retreating, a different landscape emerged, the Mammoth Steppe. Vast grasslands spread across Europe, Russia, North America. This was the domain of megafauna. Woolly mammoths, giant ground sloths, saber-toothed cats, dire wolves. The cold expanded their territory, but also made survival harder. Competition intensified. Food grew scarcer. And beneath those frozen grasslands, something else happened. Carbon was locked away. Cold soils trap organic matter, preventing decomposition. CO2 that would normally return to the atmosphere through decay stayed frozen in the ground. This created a feedback loop. Less atmospheric carbon meant less greenhouse warming, reinforcing the freeze. Earth was eating its own warmth. Fact 14. When monsoons failed. While the north froze, the tropics withered. Rainfall belts that normally brought life-giving monsoons to India and Africa shifted southward. The Sahara, which had been greening during the warming period, began its transformation back into desert. Rivers in India slowed to trickles. Communities that depended on predictable rains faced sudden drought. This is crucial to understand. The Younger Dryas wasn't just about cold. It was about disruption. Climate patterns that had held steady for thousands of years suddenly broke. Rainfall arrived at the wrong times, in the wrong places, or not at all. Societies adapted or starved. Fact 15. The Bipolar Seesaw. Here's where the mystery deepens. While Greenland froze, Antarctica warmed just slightly, but measurably. Ice cores from both poles tell opposite stories during the same time period. This phenomenon, called the bipolar seesaw, suggests that Earth's climate operates through connected systems. When the North Atlantic cools, heat builds up in the south. The mechanism: ocean currents. Like a seesaw, when one side goes down, the other rises. Heat that normally flows north via ocean currents got trapped in the southern hemisphere. This imbalance reveals the Younger Dryas wasn't just random chaos. It was a specific failure mode of Earth's climate system. Pattern, a signature, and patterns can repeat. Fact 16. Arctic air unleashed. The jet stream, that river of fast-flowing air circling the planet, began to wobble and meander. Normally, the jet stream acts like a fence, keeping Arctic air penned in the north. But during the Younger Dryas, that fence broke. Cold air masses plunged south, reaching latitudes that hadn't felt such cold in thousands of years. Britain, which had been warming, was suddenly buried under permafrost again. You can see evidence in the soil profiles: permafrost wedges, frozen ground structures that only form under sustained extreme cold. The jet stream's instability also brought wild weather swings. One year might bring crushing cold, the next a brief, confusing warmth before winter returned with vengeance. Predictability vanished. For human societies, this uncertainty was perhaps more devastating than the cold itself. Fact 17. Glaciers on the march. Mountain glaciers, which had been retreating, reversed course. From the Alps to the Rockies, from the Andes to the Himalayas, ice advanced again. Glaciers carved fresh U-shaped valleys, grinding rock into powder, leaving behind moraines, piles of debris that geologists use to reconstruct ice extent. These aren't subtle features. They're massive earthworks, proof of ice's power. In Norway, glaciers surged down valleys that had been ice-free for centuries. In Scotland, corries filled with new ice. In the American West, alpine glaciers pushed forward, obliterating any signs of previous warming. Ice was reclaiming territory it had surrendered. Fact 18. The pause in rising seas. For millions of coastal organisms, the Younger Dryas brought unexpected stability. Sea levels, which had been rising steadily as ice sheets melted, suddenly paused. For over 1,000 years, the ocean height stabilized. Coastlines stopped migrating. Tidal zones settled into equilibrium. This pause is visible in coral reef terraces and beach ridges around the world. Why? Because water that should have been flowing into the ocean was being locked back into ice. The pause gave coastal ecosystems time to establish, but it was only a reprieve. When the Younger Dryas ended and warming resumed, seas rose even faster than before, as millennia of frozen water was released in geological moments. Fact 19. The methane mystery. Something else crashed during the Younger Dryas: atmospheric methane. Ice cores show methane levels dropped by half. This is significant because methane is a potent greenhouse gas, produced mainly by wetlands, swamps, and thawing permafrost. The drop tells us that wetlands shrank dramatically. Swamps dried out or froze solid. The Earth's natural methane factories shut down. This amplified the cooling. Less methane meant less atmospheric heat trapping, which meant more cooling, which meant more wetlands freezing, another vicious feedback loop. Methane also provides clues about tropical wetlands. suggesting the impact wasn't just northern. Even tropical swamps contracted, indicating a global drying trend that accompanied the freeze. Fact 20. The sun stays silent. One potential culprit could be ruled out immediately: the sun. Scientists examined solar output proxies, isotopes created by cosmic rays hitting Earth's atmosphere, which vary based on solar activity. And the results showed solar output remained steady through the Younger Dryas. No dramatic dimming, no sunspot collapse, no solar minimum that could explain such catastrophic cooling. This was crucial. It meant the trigger was Earth internal. Something about our planet's own systems, oceans, ice, atmosphere, had flipped a switch. The sun was innocent. The call was coming from inside the house. This realization focused research on Earth's internal climate machinery, particularly the ocean currents that distribute heat around the globe. The question became, what could shut down the ocean's heat engine? Fact 21. Lake Agassiz, the mother of all floods. Now we arrive at the leading suspect in this ancient mystery. Picture a lake larger than all of North America's Great Lakes combined. Lake Agassiz, held back by melting ice sheets, was a proglacial monster, a temporary reservoir of meltwater from dying glaciers. For thousands of years, it sat there, growing, waiting. Then, catastrophically, it found an exit. The prevailing theory suggests that around 12,900 years ago, Lake Agassiz burst through its ice dam and emptied into the North Atlantic Ocean. We're talking about a volume of fresh water equivalent to all of Earth's modern rivers flowing simultaneously for an entire year. A biblical deluge. A flood that makes our modern floods look like puddles. This wasn't a gradual release. This was violence. Fact 22. Freezing the conveyor belt. To understand why this matters, you need to understand ocean circulation. The Atlantic Meridional Overturning Circulation, AMOC for short, is Earth's heat conveyor belt. Warm, salty water flows north from the tropics. As it reaches the cold North Atlantic, it cools, becomes denser, and sinks deep beneath the surface. Then it flows back south along the ocean floor, completing the loop. This sinking, called deep water formation, is the engine that drives the whole system. But fresh water doesn't sink. It's too light. And when Lake Agassiz dumped an ocean's worth of fresh water into the North Atlantic, it was like throwing a wrench into a running engine. The surface layer became fresher, lighter, less able to sink. Deep water formation weakened, maybe even stopped entirely. And when the heat conveyor belt stops, Europe freezes. Fact 23. Flipping off Europe's radiator. People often marvel at how mild Europe's climate is, given its latitude. London sits at the same latitude as Labrador, Canada, yet London rarely sees the brutal cold of Canadian winters. Why? Because the AMOC delivers tropical heat to Europe's doorstep. It's like having a radiator constantly pumping warm water through your house. Now imagine someone turned that radiator off. That's what the Agassiz flood may have done. Without that heat delivery, Europe's true polar latitude was exposed. Temperatures plummeted. Ice returned. The continent that should have been warming toward Neolithic agriculture was thrust back into tundra conditions. And the effect rippled outward, cooling the entire North Atlantic, disrupting global atmospheric circulation, triggering droughts in distant continents. One flood, planetary consequences. Fact 24. Heinrich Event 0, the Iceberg Armada. But Lake Agassiz wasn't the only player in this drama. Around the same time, massive ice shelves around the North Atlantic were collapsing. This event, called Heinrich Event 0, sent armadas of icebergs drifting south, calving from glaciers in catastrophic pulses. Each iceberg was a floating reservoir of fresh water, melting as it drifted, adding even more buoyant fresh water to the ocean surface. Ocean floor sediments preserve the evidence. Layers of ice-rafted debris, rocks dropped from melting icebergs. These weren't small icebergs. Some were the size of cities, and there were thousands of them, a frozen fleet drifting south through waters that should have been warming. Every iceberg that melted added to the fresh water cap on the North Atlantic, further weakening the AMOC, further choking off heat delivery. A 1-2 punch. Flood plus icebergs equals climate catastrophe. Fact 25. The deep ocean speaks. To confirm this theory, scientists needed to look beneath the waves. Deep ocean sediment cores revealed the smoking gun. During the Younger Dryas, the chemical signature of North Atlantic deep water formation nearly vanished. The ocean floor tells us that the great engine of deep circulation had indeed shut down or severely weakened. Meanwhile, tropical oceans showed heat building up. Without the northern AMOC pulling warm water north, heat trapped in the tropics. Surface temperatures in the Caribbean rose slightly even as the North Atlantic froze. This heat imbalance, cold north, warm tropics, is exactly what you'd expect if the conveyor belt stopped running. The ocean remembered, and its memory was written in mud. Fact 26. The two-phase shutdown. Modern climate models suggest something even more nuanced, a two-phase collapse. First, a slowdown. The AMOC weakened gradually as fresh water began affecting surface density. This initial slowdown would have caused modest cooling, perhaps uncomfortable but survivable. But then, the system hit a tipping point, a threshold beyond which the weakening became self-reinforcing. Imagine a car sliding on ice. First you lose a bit of traction, then suddenly you've lost it all. The second phase was the full stall, when deep water formation essentially ceased. This is when temperatures would have plunged most dramatically. Models suggest this two-phase process could explain the rapid onset. A few decades of warning followed by catastrophic collapse. Tipping points are terrifying because they're invisible until you've crossed them. Fact 27. The skeptics push back. But not everyone accepts the Lake Agassiz flood theory. Critics point out timing issues. Did the flood happen early enough? Was it routed to the right place? Some models suggest the meltwater might have drained through the Mississippi River system, reaching the Gulf of Mexico instead of the North Atlantic. And if that's true, it wouldn't have disrupted the AMOC. The debate rages in scientific journals even today. Other researchers argue the flood volume has been overestimated, that it wasn't large enough to shut down ocean circulation. They point to alternative routes, different dates, conflicting geological evidence. Science, at its best, thrives on such disagreements. Each critique forces researchers to refine their models, gather more evidence, test assumptions. The truth is still emerging from ice and stone. Fact 28. Wind patterns as amplifiers. Perhaps it wasn't just one thing. Perhaps the flood triggered an initial cooling, which then triggered atmospheric changes that amplified the effect. Climate models show that wind patterns can shift dramatically when ocean temperatures change. If the North Atlantic cooled, atmospheric pressure systems would reorganize. The jet stream would wobble. Arctic air masses would push south more frequently. These wind changes could have pushed cold air masses southward, creating feedback loops. Cold air chills the ocean surface, which makes deep water formation even harder, which reduces heat delivery, which makes the air colder. Cascade. This idea suggests the Younger Dryas wasn't a simple cause and effect but a complex system's failure, multiple feedbacks reinforcing each other until the climate locked into a new, colder equilibrium. Fact 29. Coral conformation. Far from the frozen north, tropical corals recorded the AMOC shutdown in their growth bands. Caribbean corals showed cooling of about 3 degrees Celsius during the Younger Dryas. This might not sound dramatic compared to Greenland's 10-degree plunge, but in tropical waters, this is profound. Coral growth slowed. Ecosystems shifted. The tropics weren't immune, They were just experiencing a different flavor of the same catastrophe. These coral records provide independent confirmation that ocean circulation had indeed changed. The patterns match what you'd expect from AMOC weakening. Reduced heat transport to the north means less heat pulled from the south, causing modest southern cooling. Every proxy, from ice to coral to lake mud, tells interlocking parts of the same story. Fact 30, the sudden reboot. And then, as mysteriously as it stopped, the AMOC roared back to life. Around 11,700 years ago, deep water formation resumed. The ocean's heat conveyor belt rebooted, and all that heat that had been building up in the tropics suddenly flushed north in what scientists call a thermal whoosh. Greenland warmed 10 degrees in decades. Europe thawed. Forests marched north again. The abruptness suggests the system crossed another tipping point, this time back toward warmth. What triggered the restart? Perhaps enough ice melted that freshwater input declined. Perhaps ocean salinity slowly increased until surface waters could sink again. Perhaps both. The mechanics are still debated, but the result is clear. Earth's climate flipped from ice to warmth almost overnight, geologically speaking. And with that warming, human history took a new path. Fact 31, the vanishing hunters. In North America, something changed at precisely the wrong time. The Clovis people, North America's Ice Age hunters, famous for their distinctive stone spear points, vanished from the archaeological record right around 12,900 years ago. Their disappearance coincides eerily with the Younger Dryas onset. For decades, archaeologists debated, did climate kill them, or was it overhunting of megafauna? Probably both, intertwined in a tragic feedback loop. Imagine being a Clovis hunter. Your people have perfected the art of killing mammoths, mastodons, giant bison. Your culture revolves around these great beasts. Then the climate shifts, cold returns, grasslands change. The megafauna populations, already stressed by hunting pressure, begin collapsing. Mammoths die off. Food sources disappear. Without mammoths, Clovis culture couldn't sustain itself. The tools, the knowledge, the social structures, all built around megafauna hunting, became obsolete nearly overnight. The Clovis people didn't disappear. They adapted, evolved, became something else. But their distinctive culture ended when winter returned. Fact 32, desert farmers of the Levant. On the other side of the world, in the Middle East, a different transformation was beginning. The Natufian people were semi-sedentary foragers living in the Levant around 12,500 BCE, just before the Younger Dryas. They harvested wild grains, wheat, barley, using sickle blades. They built permanent structures. They were on the cusp of something revolutionary. Then the rains failed. The Younger Dryas brought drier conditions to the Middle East. Wild grain yields dropped. Predictable food sources became unpredictable. The Natufians faced a choice: abandon sedentism and return to mobile hunting, or find new ways to secure food. Some became more mobile, but others doubled down on an experimental technology: farming. In the centuries after the Younger Dryas, during a period called the Pre-Pottery Neolithic A, the descendants of the Natufians began deliberately planting and cultivating crops. Climate stress may have been the crucible that forged agriculture, humanity's most transformative technology, born from desperation and innovation. Fact 33, the mysterious pillars of Gobekli Tepe. In southeastern Turkey, on a windswept hilltop, stands archaeology's greatest enigma, Gobekli Tepe. Its T-shaped stone pillars covered in carved animals, its circular enclosures carefully aligned, its sheer scale and sophistication, was built around 11,600 years ago, just as the Younger Dryas was ending. No pottery, no evidence of agriculture, just hunter-gatherers organizing to build something monumental. Why? For whom? What drove them? Some researchers point to the so-called vulture stone at Gobekli Tepe, which depicts a scorpion, a bird, and other symbols. A fringe theory suggests this is astronomical, recording a comet swarm that caused the Younger Dryas. Mainstream archaeology is skeptical, the interpretation is speculative, the astronomical alignment's debatable. But here's what's undeniable. As the world warmed again after the freeze, human ambition exploded. The end of climate chaos coincided with the dawn of monumental architecture. Perhaps surviving the Younger Dryas gave people new perspective. Life is fragile, so build something that lasts. Fact 34. Australian wanderers. Even distant Australia felt the Younger Dryas' ripple effects. Aboriginal sites across the continent show a wet-to-dry shift during this period. Waterholes that had sustained communities for generations began drying up. Rock art locations changed, suggesting people were forced to relocate to more reliable water sources. Australia's climate doesn't track precisely with Greenland's. It's too far from the North Atlantic. But global atmospheric reorganization affected rainfall patterns everywhere. The Younger Dryas wasn't just Northern Hemisphere cold. It was a planetary reshuffling of where rain fell, where rivers flowed, where life could sustain itself. Australian Aboriginal peoples, with 65,000 years of deep environmental knowledge, adapted. They moved. They adjusted their songlines, their territorial boundaries, their water management strategies. Survival required flexibility. Fact 35. Highland exodus in South America. In the Andes, high-altitude settlements were abandoned. Archaeological evidence shows that people living at higher elevations during the warming period before the Younger Dryas retreated to lower, warmer valleys when the freeze returned. This makes sense. Already marginal lands became uninhabitable. Glaciers advanced. Growing seasons shortened. Freeze-thaw cycles intensified. Moving to lower elevations wasn't just practical. It was survival. But this created new pressures. Lower valleys were already occupied. Resources were finite. Population density increased. Competition grew. The Younger Dryas forced communities into closer proximity, which may have accelerated cultural exchange, conflict, innovation. All the pressures that drive social complexity. When the world warms again, these valley populations would eventually return upslope, but carrying new knowledge, new technologies, new social structures forged in the crucible of the freeze. Fact 36. The cave art explosion. Across Europe, something remarkable happened during the coldest centuries. Cave art flourished. Lascaux, Altamira, Chauvet, many of the most spectacular painted caves date to this period or just before. Why paint in the deep dark when survival was precarious? Some archaeologists speculate these weren't just art. They were ritual, magic, desperate attempts to summon the warmth and abundance that had vanished. Imagine shamans painting by firelight, invoking the spirits of bison and horses. Perhaps they believed the painted animals would become real, would return to the frozen steppe and provide food. Perhaps the caves themselves were sacred spaces where the boundaries between worlds were thin, where human supplication might reach the powers controlling the seasons. We can't know their thoughts, but we can feel their desperation and their hope, painted forever on limestone walls. Fact 38. Innovation through scarcity. Some theories suggest smaller group sizes during the Younger Dryas cold may have paradoxically increased innovation. With resources scarce, competition intense, and survival marginal, every advantage mattered. Small groups that innovated better tools, new hunting techniques, improved shelters, survived. Those that didn't perished. This selective pressure may have accelerated technological and social innovation. There's archaeological evidence for increasing tool complexity during this period. More specialized points, more efficient butchering techniques, better cold-weather clothing using needles and sewn hides. The Younger Dryas may have been humanity's crucible, where the lazy and complacent were filtered out, leaving only the clever and adaptable to seed the post-glacial world. Fact 39. The agricultural trigger. There were no mass die-offs of human populations that we can detect. Humans proved remarkably resilient, but the stress was real. And in the Middle East particularly, that stress appears to have accelerated the single most important transition in human history, from hunting and gathering to farming and herding. Agriculture didn't emerge in comfortable times. It emerged from necessity. Wild foods became unreliable. Populations couldn't simply move. Territories were full. So they experimented. They planted seeds. They protected wild herds. They domesticated grains, then animals. By 10,000 years ago, full agricultural societies were emerging in the Fertile Crescent, growing from experiments born during the Younger Dryas stress. Without that freeze, would agriculture have emerged when it did? Perhaps. Perhaps not. Fact 40. The Great Freeze in Memory. Around the world, indigenous oral traditions speak of great freezes and catastrophic floods. From Native American stories of world-ending cold to Aboriginal Australian tales of climate chaos, cultural memories may preserve echoes of the Younger Dryas. These aren't historical records in the modern sense. They're mythologized, transformed through countless retellings over 500 generations. But the kernel might be real. Did ancient peoples remember the world freezing? Did they pass down stories of winters that wouldn't end? Of animals disappearing? Of desperate migrations? We'll never know for certain. But it's haunting to consider that the campfire tales told across the globe might preserve humanity's collective memory of the day winter returned. These stories connect us across the vast gulf of time to ancestors who survived the unsurvivable. Fact 41. The lesson of abrupt change. The Younger Dryas shattered a comfortable assumption that scientists had held for decades. Before ice core evidence revealed its violence, researchers believed climate changed slowly, centuries, millennia. Ice ages came and went like tides, predictable and gradual. But the Younger Dryas proved Earth's climate can flip like a light switch when critical thresholds are crossed. This is the Younger Dryas' most important lesson for us today. We live in a time of rapid climate change driven by human activities. Global temperatures are rising, ice sheets are melting, oceans are warming, and the Younger Dryas whispers a warning. These systems can surprise us. They can change faster than we think possible. They can cross invisible tipping points and cascade into new states before we realize what's happening. Complacency is dangerous when dealing with Earth's climate. Fact 42. Greenland's meltwater history echoing. Right now, today, Greenland's ice sheet is melting at accelerating rates. Billions of tons of fresh water are flowing into the North Atlantic each year. Not the catastrophic pulse of Lake Agassiz, but a steady stream that's measurably affecting ocean salinity. Scientists monitor this nervously because they know the history. They know what fresh water can do to the AMOC. They're watching for early warning signs. The parallels aren't perfect. The modern world is warmer overall due to increased CO2, which provides a buffer against full AMOC collapse. But regional effects are still possible. If the AMOC weakens significantly, Europe could face cooler winters even as the globe warms. Rainfall patterns could shift. Tropical regions could see major disruptions. The ghost of the Younger Dryas haunts climate science. Fact 43. Warning signs in ocean salinity. In 2023, a study analyzed ocean salinity patterns and found something concerning. The fingerprints of AMOC slowdown were appearing in the data. Subtle changes in salinity gradients, slight shifts in current speeds, early indicators that the Great Conveyor Belt might be weakening. Not collapsing, not shutting down, but wobbling. This sparked intense debate in the scientific community. Some researchers argued the changes were within natural variability. Others saw genuine cause for concern. Climate models were run and rerun testing scenarios. The consensus settled on cautious monitoring. The AMOC is changing, we need to watch it carefully, but we're not facing an imminent Younger Dryas scale collapse. Yet, the word hangs in the air. Yet. Fact 44. CO2, our safety buffer. One crucial difference between now and 12,900 years ago: atmospheric carbon dioxide. During the Younger Dryas, CO2 levels were around 240 parts per million. Today, we're over 420 ppm and rising. This matters because CO2 is a greenhouse gas. It traps heat globally. Even if the AMOC weakened or stopped, the extra CO2 would prevent the kind of catastrophic global cooling the Younger Dryas brought. Regional effects are still possible, but ice age conditions aren't. This isn't reassuring news for climate change. Higher CO2 brings different disasters: sea level rise, extreme weather, ecosystem collapse, ocean acidification. But it does mean we won't face a sudden return to tundra and mammoths. Our climate crisis looks different from our ancestors' crisis, even if both involve human survival challenges. The past doesn't repeat exactly. It rhymes. Fact 45: Holocene stability, fragile luck. For 11,700 years since the Younger Dryas ended, Earth's climate has been remarkably stable. This stable period, the Holocene, allowed agriculture to flourish, civilizations to rise, cities to be built, technologies to develop. Every human achievement of the past 10,000 years happened during this unusual climate stability. We treat it as normal, as permanent, but the Younger Dryas reminds us, stability is the exception. For most of the past million years, Earth's climate has been wildly variable. Abrupt shifts, dramatic swings, rapid changes. The Holocene's gentle stability was rare luck, possibly influenced by orbital cycles, ocean configurations, greenhouse gas levels. A Goldilocks combination that won't last forever even without human interference. We evolved during chaos. We built civilization during calm. And now we're testing whether that calm can survive our impact. Fact 46: the Comet hypothesis, fringe speculation. Now let's address a popular alternative explanation that's captured public imagination: the Younger Dryas impact hypothesis. This theory proposes that fragments of a comet struck Earth around 12,900 years ago, causing massive fires, injecting dust into the atmosphere, and triggering the cold period. Proponents point to layers of platinum, nanodiamonds, and black matte sediments at sites across North America as evidence. The hypothesis is championed by some researchers and popularized by writers like Graham Hancock. But mainstream science remains unconvinced. The platinum anomalies aren't consistent across sites. The nanodiamonds can form through natural processes. The black mattes appear at different times in different locations. Multiple independent reviews have found the impact evidence lacking or inconclusive. That doesn't mean it's impossible, just that the evidence doesn't currently support it. Science follows evidence, and the ocean circulation explanation has far more robust, consistent, reproducible data supporting it. Fact 47: the missing crater. If a comet caused the Younger Dryas, where's the crater? Impact proponents suggest an airburst, the comet exploding in atmosphere without leaving a crater, like the Tunguska event of 1908. They point to sites like Abu Huraira in Syria, where some claim to see impact signatures in vitrified materials. But airburst evidence should be widespread if it was powerful enough to trigger global climate change. The distribution of supposed impact markers is patchy, inconsistent. Nuclear chemists have examined the proposed vitrified glass and found it more consistent with building fires than cosmic impacts. The airburst explanation keeps the hypothesis alive but doesn't solve its evidentiary problems. Still, it's investigated. Science doesn't dismiss ideas just because they're unlikely, it tests them. And so far, the tests haven't supported the impact hypothesis. Fact 48: modeling the future. Today's climate scientists use the Younger Dryas as a test case for their models. Can our climate models reproduce the Younger Dryas when fed the right inputs: fresh water flux, ocean circulation changes, atmospheric responses? If a model can successfully simulate past abrupt climate changes, we gain confidence it might accurately predict future tipping points. This work has practical urgency. We need to know, How much Greenland melt triggers AMOC disruption? How fast could changes happen? What early warning signals should we monitor? The Younger Dryas provides real-world data to validate these models, turning ancient history into a laboratory for understanding tomorrow. The past becomes prologue. Fact 49. Geological time versus human time. Here's a perspective that's both humbling and terrifying. The Younger Dryas lasted 1,200 years. To us, that sounds like an eternity. 1,200 years ago, the Crusades hadn't started, the Americas were unknown to Europe, the printing press didn't exist. 40 human generations, a span that would encompass all of modern history. But to Earth, 1,200 years is an eye blink. In the 4.5 billion year story of our planet, the Younger Dryas is barely noticeable, a brief flicker of cold between ice age and warmth. This disconnect between human experience and geological time is hard to grasp. What feels permanent to us, our cities, our civilizations, our climate, is temporary on Earth's timescale. The Younger Dryas puts our mortality in perspective. We are brief. Our works are brief. But the systems we're affecting, oceans, atmosphere, ice, operate on timescales that dwarf human history. Fact 50. Where woolly rhinos waited. And so we return to where we began, imagination. Close your eyes one last time. Picture the world 12,000 years ago. Snow covers lands where cities now stand. Glaciers grind where farms now grow. And across the frozen steppe, woolly rhinoceroses graze under shimmering northern lights, breathing clouds of frost into the dark polar night. They're waiting for spring that's been delayed for 1,000 years. They don't know why winter returned. They don't understand ocean currents or tipping points or fresh water pulses. They just endure, generation after generation, eating hardy grasses, avoiding predators, surviving. And then, one season, maybe not this year, maybe not next, but soon in geological terms, the warmth returns. The ice retreats. Forests march north. The woolly rhino's world transforms, and they must transform with it or vanish. As you drift towards sleep, carry this image with you. Patience in the face of forces beyond comprehension, endurance through winters that seem endless, and the eternal truth that all seasons eventually change. The earth turns, the climate shifts, and life, resilient, stubborn, beautiful life, adapts and continues. The Younger Dryas ended 11,700 years ago. Spring came back, the world thawed, and humanity, having survived the unsurvivable, walked into a new age. Sweet dreams. May your sleep be as peaceful as the Holocene, and may you wake to gentle warmth. Thank you for journeying through deep time with me tonight. We've explored ice cores and ocean currents, ancient floods and human resilience, scientific mysteries and fringe theories. The Younger Dryas remains one of climate science's most important lessons. A reminder that our planet is capable of dramatic, rapid change. That stability is precious. That tipping points are real. But it's also a testament to human adaptability. Our ancestors survived the freeze. They innovated. They created agriculture, built monuments, and laid foundations for everything that came after. If you found this journey fascinating, consider subscribing for more bedtime stories that explore Earth's mysteries. And if you have thoughts or questions about the Younger Dryas, leave them in the comments below. Until next time, sleep well. Dream of ice and stone, of ancient peoples huddled around fires, of spring returning to a frozen world.